Welcome back. Hope you're all good. Hope you're having a good whatever day it is. It's Tuesday, I think. It's been a bit of a just at the computer all day for me. So it's a nice break to actually talk. Hope you're all doing well. Yeah, let's get into it. So on to practical stuff. So we went through the course. We're going through, we'll get back to where we were. So we went through lots about sorting, a little bit about data structures, a little bit about dictionary sets and arrays, and this thing called a heap that you can use for a priority queue that's going to come back. So I'll make sure I'm actually sharing my screen. Sorry. Whoops, you're just looking at me talking while I read the screen. Yeah, so we went on to heaps and did a bit of timing, show its nlog n, a little bit about merge sort and tiny talk about quicksort. So then we introduced a tiny bit about Unix and using the command line. So plan for this lecture is to give you some demos of driving around so you feel really comfortable. If you're already comfortable, this will be pretty familiar stuff for you. But if you've never done it before, which seems like lots of you hadn't done it before, so hopefully this is nice and you can start having a play around and do it yourself. So last time I just spent a little bit of time talking about Unix itself, what it is, what it was, and about the file system. So that it's a tree and you have these commands for traversing the tree. So I should say, just to start with, it's like in the file system, everything's sort of a folder or a file. So if you go to a folder, you go inside it, there'll be more folders or files. It's this tree structure down where you're going to go. It's either like a node or a leaf. If you're thinking about it as that sort of graph, and the leaf will be a file every time. So the main things for file navigation is ls. So I think this is a good one to do. I'll go to somewhere more benign. I have this deep paranoia because it's my work laptop that I'm going to show you guys something on the internet that I'm not supposed to show. So I'm going to be really careful. So I'm navigating around. So I'm in my base directory. So if you go CD, you'll go back to your home directory. If you want to see where that is, it's home Paul Billette on this computer. And for your computer, it will be something different. Whatever you've called it. And if you're on Windows, it will have a C/ blah, 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 blah. PWD, print working directory. And if I want to go, okay, what's here? ls. That will give me a list of stuff. I keep all my source code in a directory called source. There's a bunch of stuff there. So the one we're interested in today is UQ demos. So we're going to go change directory to UQ demos. And there's some stuff in there. So basic navigation, if you want to go down a directory level, cd ... You can do a few of these in a row. Now I'm actually below my home directory, so I can go cd Paul Billette, cd source, and I'm tabbing. That little noise is my computer warning me that there's more than one thing to show. And UQ demos. Easy. So going up and down, traversing ls. I've got some stuff in here that's, we'll go through a little bit today. Another one that's useful is ll. Just gives you a little bit more information. There's a little bit to unpack here. So this will give you some information about so there's directories here, but these ones are the files that you're interested in over here. So there's this couple of Julia files, a couple of text files, and a shell script. It gives you the size information over here. With all these low-level command line utils, you can usually go ---- help. You'll find out that it's far more complicated than I've been making out by just doing stuff. And you have all these optional arguments that will give you some stuff that will give you help. Like if you don't want to do certain things or you want to block things, do different things, or a whole bunch of command line options that you can do to fiddle with this stuff. So that's another useful one. We've got ls that just lists a bit more information in ll. Stuff over here is about permissions. I'll talk a little bit about that later. That's useful for when you're making some stuff. Hope that's clear. So that's simple stuff, traversing up and down the directories. Cool. What have we got here? So we gave you a bunch of lists of stuff. Yeah, so this little squiggly character, I want to call it a tilde, is to go back to that. If I go just cd, I end up in this directory, which I want to know what it is, print working directory, home, all that. So this guy's like a shortcut for that. So I can go cd. It's sort of stupid doing it from this place, but that. So if you want to jump somewhere else with that at the start, you don't want to go back and work out what it is. You can always, if you want to navigate from your home directory out, you can use that little squiggle. That's the basic ones. Okay, so now we'll do a little bit of manipulation. So these ones are fun. So again, if you want help, RM's one, minus help. I'll keep saying this, same for the Julia stuff. It's like, read the help. The help explains it better than I do, and it will be less likely to be wrong. Sorry. Yeah, less likely to be wrong. So there's a bunch, again, there's a bunch of options. So what this guy is for remove. So if we want to make files, remove files, that's what we're going to talk about for a little bit now. So let's go, let's make it. There's a few missing here. So let's try something like, got some stuff in here. Let's go down one and we'll make a directory, make the test. So now if I look, I've got this thing called test. I can change directory to test and there's nothing in there. Okay, cool, that was silly. What did I do that for? I want to get rid of it. RM is for remove. Remove will only move files unless you do it recursively, which I'll say in a second. So if I try and go RM test, it'll go, it's a directory. You can do RM for test. And you look and it's gone. So make the test. You can also do RM minus RM test. That removes it recursively and all the stuff in it. I'll get rid of it too. Cool. So if we want to make a folder, we can do that. We're going to move some stuff around. We can do this too. So we can copy and move. So again, if you've used Windows, you should understand the difference between, I'm just going to copy this thing to a new place or move it somewhere completely different. Yeah, so let's try this. So we've got some files here. I'm going to copy intro text. So again, stinging because there's more than one option. Somewhere new. So now I've got a thing called test.txt and it should be the same as intro. So I just made a straight copy of it. So I'm going to get rid of that test.txt. And it's gone. I could also move it. So it's just like copy. Instead of taking it and making another copy, I can just basically like move it to a new place with a new name. I won't necessarily show you that one now because it's basically straightforward. So the one for this one is you're going to have your source. So that's the thing and the destination. So that can be a new thing. So source, destination. That's for copy and move. And again, if you want help, there's lots of options. Most of the options will be that are useful for you guys are this -R1. So if you want to do it recursively, like take all the things in here and put them all over there. They're the ones you'll do. Bunch of other options. They're not so hard. Well, we're not just trying to give you a taste of all the stuff you're going to want to do at the command line, all really useful little things. Yeah. That's in terms of moving stuff around and copying things. There's more functions that are useful for looking at text files in particular, a few more useful things. So echo is a useful one. So echo, it might not seem useful, but that's what I got. Yeah, so let's just do that. So it just prints whatever's in the string. So this would count for a hello in a shell script, a hello world. So just echoing hello. Usually when you're writing a bash script, you have a variable and you might want to construct things and echo that's the sort of thing you'll be trying to do. Other ones for looking at text files. So cat is really useful. So cat will print out whatever's in the thing. So let's look at one of these Julia files. Oh, it doesn't have an end line, so it's done something funny. So that's just gone. If I was to look at this guy in VS Code, if I look at hello.jl, it's just this guy, print line, hello from Julia. So pretty simple. So cat will just print everything in the file. If you have a really big file, it will go blah. So you don't necessarily want to do that for printing to the terminal. If you want to just if you're hacking around and you want to see, so you get an idea of what's in a file, one of the things you might do is this thing called head. So what that will do, for this one, it does the same thing. If we have a bigger file, what it will do, again, head's pretty simple one. It will print the first 10 lines of each file to stand it out. And you've got a bunch of arguments you might want to do. So if it's this is really useful for, say, you've got some big CSV data or something you download off the internet and just go, oh, what's in it? What's the header? To try and understand if you got the thing you actually wanted, you might do this. Head's friend is tail, where it does the opposite. Tail will print the bottom 10 lines. So if you want to see what's at the end, that's what that guy's useful for. Lots of stuff really quick. So that's for some simple stuff for looking for text files. So we've got cat, head, tail. Diff is useful. Another one that's useful. What this will do is, so I've made 2 files here. I wrote intro 1. So it was a dark and stormy night. So that's the first one. And then imagine you've gone to edit this thing, you fixed up night, and then fallen asleep on the keyboard for the last line. So it was a dark and stormy night. It's nonsense. What Diff will do is it will compare line by line through 2 files and tell you where the mistakes are. So Diff, if you do it without this optional argument, it's a little bit arcane. It will tell you which line, this little code here, 7C8, will tell you where to do it. If you do it a bit more human readable, will be minus Y argument, where it will say on the left, it was a dark and stormy night. It was a dark and stormy. This guy's different, and there's this new thing here, which is useful for comparing 2 files. There's lots of arguments for diff. So diff minus help. You can see lots of things you might want to do, just as simple. So hopefully you can see that being useful straight away. Getting up into more power user tools. So wouldn't expect you guys to be necessarily using these last ones. grep is a really useful utility for searching text files. What grep will do is it will search a file. So grep option patterns file. So you're basically looking for a string in a file. So if I went grep night, it's not in that one, but it is in, not so useful there, but it is in a file. So just the basic one of looking like that is going, oh, grep night is in intro 2. If you want to search through all the files, you can do with a recursive option. And it will say, oh, in intro 2, you do find this string night. The pattern matching is much more advanced than just the strings. You can do regular expressions and things like that. Much more complex things you might want to be looking for looking through text files, looking through files and trying to find patterns. So I also made mention here of 2 old school editors, Vim and Emacs. They're a little bit weird, but again, it's like, usually when you're on the command line, it's a limited environment, so you'll often be using a terminal for logging onto a server or something. So when you're using things on the internet, like you're doing cloud computing and you want to see what's going on another computer, you can log onto that computer and all you get is a terminal. So this is why this stuff's so useful, because they don't bother putting the things for doing display on there if they don't need to. So using these command lines and having a simple editor. So Vim is one I am much more familiar with than Emacs. It's a weird one in that if I go and try and type, strange things happen. It's called a modal editor, where you have different modes. You have an edit mode, where you go into, what you do is you have all these keyboard shortcuts. There's no mouse clicking around. You press Shift-I, and then you can go and add stuff to this. And then you have to exit that mode. And then you can do pattern matching within here. So I can do, if I type /Stormy, it will find Stormy for me and search through. You have all these tools. So it's a bit of a weird editor compared to what you used to these days, but it's really useful. Oh. Okay, just as an intro, you might have to use that sometime. It's not that bad. Again, it's one of these old school tools and the learning curve's pretty steep, but it's really powerful. Some people who are magical at Vim and they know all the shit with the keyboard shortcuts and they seem like they're doing too much, like they're not pressing many keys and a lot of stuff's happening when people are really good at using Vim. Cool, so that's some basic texty types tools. Yeah. Okay, so big thing about Unix is you can chain things together. So you can pipe, this thing's a pipe, so this symbol here, you can pipe the result of one thing into another thing. And you can redirect it into a file with this guy. So for example, if I go echo hello, I just go hello, but if I go into a file, let's make one up. So now if I look in here, I've got this thing called test2 as emerged. If I used my text editor in test2, you should see it's got hello in it. So remove it. So this is a really quick survey of just hacking around in a terminal. So basically got all those ideas. This idea of taking the result and putting it into a file or piping it into another thing lets you do quite complex stuff. This is the sort of beauty of this environment, is you have all these simple tools. So the interface for a human is really sort of simple, like each of these things is a program, like copy is a program, and list is a program, and remove is a program. And you can compose these nice little simple things into complex things. That's the beauty of it. It's not, I'll talk a bit about that in a second, but it's quite a powerful tool. So you have all these simple things you use in concert to do something complex. It's a really good design. It's an example of a sort of an excellent design in software. It might not seem like it, but it's not like a thing that some web app or something that people are using. But for making systems, this is sort of how you design things. You have simple things that chain together in a nice way, so you can create complex things. Cool. Okay. We've got examples of that. So it says we won't cover unless we need to. You got some file permission stuff, changing the permissions of a file. So when I went LL before, you'll see all this stuff. There's users and what they get to do. So it's like read, write. So the way to read this is R is for read, W is for write, and X is for execute, and which group. So you have different, on Linux, you have different user permissions. And so whether you can read, write, and execute at different levels. So whether the user can, whether the root user can, so like the super user, for particular things. So you see this one down the bottom, because I'm playing around, it's got way too many permissions. I'll show you that in a second, I guess. Who am I? That might be useful. That will just say who the user of the computer is. That's me, it's Paul. And sudo is for giving more permissions to do a task. So if you're going to do something that fiddles with your file system in a way, you know, download stuff off the internet. Sometimes you need, or not necessarily download stuff off the internet, but just having escalated permissions is sudo, and you have to put password in. Okay, cool. Any questions there on that simple stuff? Why does it have W? That's the read, write, read, execute is the question. So why does it have those WRX written everywhere? That's the permissions for the file. That's what this stuff over the side is. So when you go this, so I'll do this as a demo. That's in a second. We'll go through that in a bit more. So I think these guys, you should know this. I think I talked about this last time. Task manager is your friend. Top, you can see what's running. Uses all the time when I'm programming. So again, at the top line, you can see the processes running. Zoom, you can see it's PID. So this is an ID for the process. You can see how much CPU it's using. So it's 123%. So more than one core on the computer, and how much memory it's using. This is really useful. So like I've seen questions come up and it's like, oh, is Julia still running? It's like, go and check top, or go and check your system monitor if you're on Windows and see what's going on. Great, really useful one, top. Hopefully you don't need to do kill. So if you've got a process that's just gone rah, and it's running away on you, what you can do is you can get that PID that was in top and you can kill it. And you can use PS to see whatever's running. So Bash is the only thing running here, and PS itself in this session, in this terminal session. 3 useful things. Kill, yeah, sometimes you have to do that. Like usually you've written a bad program and it's eating all the memory in your computer, and you're like, oh God, everything starts to slow down and you have to kill it. If you can get into top, see it's PID, kill, or you can kill all. You guys can have a play with that. I'll say a little bit about these. So downloading stuff off the internet, you've got these 2 libraries. They do slightly different things. If you want to download stuff from a URL, you can use curl or wget. Curl is a big C library. I think it's C library. I'll say that, be wrong, but it's like, it's got lots of support for lots of different things, and you can use it within different packages. Wget's just a little utility that's on computers, but it supports recursive downloads, which I don't think curl does. Might be wrong. There are 2 things. They sort of, from a user side, they sort of do the same thing as curl or wget, whatever. So if you want to download a file off the internet, so we had examples earlier in the notes of getting something like the Shakespeare corpus, we downloaded it. You could do this from the command line too, where you use curl or wget to download these things. SSH is really useful. So this is, I was saying before, if you want to go onto another computer over the internet, so this super useful one is a secure shell. So what this will do is give you users public key cryptography to let you have a terminal session in another computer, and you can copy things off another computer. So you don't trust the network. It's the wild west of the internet. Everyone's trying to do bad things to you. You can use cryptography so that you can get a shell session in another computer. Use this one quite a lot. I won't give you a demo because I'm too paranoid. I'll show my SSH keys accidentally. I think that would be really bad. This will come up with Git. It's one of the options. Yeah, there's one. So especially on Windows, PuTTY is an easy software for SSH. So maybe you've all used PuTTY before, I'm not sure, but yeah, it's really useful. It's really handy to be able to log on to another computer. So like if you've got a computer at home and you're at uni or something, and you want to go and get a file off your computer, you can set it up so you can SSH onto your computer. Remote access, it's really useful. I'll just say really quickly about these ones is GCC is a compiler. These will come up. You'll see these things. GCC for compiling, like C code, but a whole bunch of other languages as well. Make for building projects. So this is particularly for C applications, but you can use Make for everything, and some debugging tools. So back in the old days of Linux, you would build it from source yourself. So you'd download the stuff and somehow you can bootstrap it to build your own operating system. But still useful, and you still use them. Maybe you'll see Julia complain about these things. So just showing you these things so you can, you've seen them and you have a rough idea of what they are. Make, everyone uses Make. It's very useful. Okay. So one of these things you can do that I wanted to give you a brief demo is you can make a script in Bash that lets you run a bunch of different stuff. So this is a shell script. I've made one here. I'll use VS Code just so it's easier to look at for everyone. I've made a thing that does a bunch of these things one after the other. So what I'm going to do is, you've got this thing called a shebang at the front. Tells you which, I think it's for the kernel, but don't worry about that. You basically, like a magic spell, you put at the front so that you know to run it with the shells, whatever shell thing you're using. So Bash in this case for me. What this guy will do is it's just a bunch of these things I was just talking about. So it's going to make a directory called test. It's going to cd into test, so change directory to test. I've made a variable called file name, it's called output.txt. What I'm going to do in this bash script is run Julia with this file hello. Now, I've had to do the ... because I've cd'd into test from this base directory. So hello is one below me. And what I'm going to do is take the output of hello and put it into, don't do that, put it into this file name variable. So that's output.txt. And then I'm going to go echo, I wrote a file called file name. Magic. So you can make little scripts to do a bunch of stuff for you. So what that will look like is I go .-test.shell. Oh. File not found. Directory. Oh, what happened? I broke something. Oh. Why you don't do live demos. File name not found. What did I change? Anyway, I'll fix that up and show you later. I just wrote this really quickly, so I'll fix that. I'll fix that and we can show you later on. So that was embarrassing, but we'll get there. I'm not going to spend too much time on it though, but just the idea that you can make a bash script, put it all together, do a bunch of stuff all in one go. It's useful. Cool. When I make a shell script, if I make a new one, so let's just make a new guy. File, new file. I'm not in Vim anymore. Save. Okay, so I've got this test2.shell. If I look at this guy, you'll see that the permissions are different between these ones. So test that one before has all these elevated permissions. So the way you run a bash script is to go .-test2 permission denied. What you can do is you can chmod. I'm going to give it the ability to execute the file, test2.ship, and I should be able to go test2. Hello. That one actually works. So I'm being too fancy with the other one too quickly and I've made a mistake, but I'll go back and fix it later when my brain will work. Okay. hopefully that's okay. So you can, again, if I go back to this test2 one, I can call Julia hello.jl. So hello.jl has got a hello world in it. So I'm going to call this Julia file from this bash script, and it should be all good. So we should be able to see hello from Julia. I'll fix up that other bash script so you've got it as a demo. But that's where we're going. So that's some basic command line stuff. Any questions on that so far? Pretty easy. Just a bunch of stuff you need to remember. You practice it as you do it. Get used to it. No questions. That's fine. Okay, cool. So this little bit, I wanted to say really quickly about Unix philosophy. This idea of how to make good software. So this is a good design for keeping control of complexity of programs. So so this comes from the guy who invented pipes. Make it basically this first one's the takeaway one. Is like make each program do one thing well. To do a new job, build it fresh rather than complicate old programs by adding new features. So just do, at least the interface is simple. Just do one thing and do it really well. Expect the output of the program to become the input of another that you don't know yet. And that way you can chain things together. This is good design, good for you, but don't fiddle with stuff. Just try and use it as quickly as you can. Don't worry about throwing stuff away. Yeah, build tools and expect to throw some of them out when you're finished with them. That's just how software works. That's really useful. It's probably more useful the further on you are down in your career. You'll be able to see what's going on. You'll be able to see how this works. But you'll start maybe with some of the little functions you've made, you start to see like, oh, complicating the inputs, having too many inputs. How do I make this interface simple? Then you're more likely to use it again. Okay, just wanted to say that. Okay, now Git. So I think this is in your homework, so you're going to have to make a GitHub repo. So what is Git and what is GitHub? I think the first place to start with this is like, what's version control? So version control, you've probably all had this experience. Like the one for me when I was an undergraduate was writing a piece of work, and you go like, write the thing, and then you go, this is version 1 in the file name. And you go, oh no, that's not quite right. I'm going to edit it. And I put version 1.1, and then I go, oh no, now it's version 2. And then I end up all these different files in my file system. And then you go, well, actually number 2 sucks. I want to go back to number 1. And it's like, oh, it's like Paul's essay, number 1, good version, you'll do that again. It's exactly the same with software. And you probably notice that when you're doing, just working with your Julia notebooks for the assignments, you've got a thing that works, and then you start hacking away, and then all of a sudden, before you knew it, it's gone. And geez, that one was actually sort of working, and now I've got this new one that's completely broken, and I don't know how to get back to where I was. Especially if you lose the session, like you can Control Z like a crazy person trying to get back to where you were. That's what version control is trying to solve. It actually gets really complex. I think Git's a complex solution. I don't think that it's the best solution. It's the ubiquitous one in industry. So everybody, I won't say everybody, no absolutes, but most people working in software use Git these days. I don't know the exact statistics, but I'd be surprised if it's like, 80, 90% everyone's using Git. Lots of people use GitHub too. Anyway, so back to version control. The design goals of version control are to keep track of what you did over time. That's like number 1. Now, you can see, you can do that with your files on your computer. You've done version 1, version 2. You can just rename the file. It's probably not the most efficient way of doing it, of keeping every change as a new file. It's one thing I'll talk about in a second. You want to be able to go back to the previous point in time and understand the history of what you've done. So like this will be a quick poll. Has anyone done that for their assignment, where they've gone like, I'm going to try and make this thing really fast, and then you break it completely and it doesn't work anymore? Has that happened to anyone? Question 3, yes, from Liam. No one else is brave. Yeah, well, happens to everyone. That's why you use version control. Is anyone actually using version control already, or let's see if anyone's. Natalie does. Cool. Yeah, GitHub. Cool. So maybe this stuff's all easy for you. Control Z from Alexandra. Yep. Just never turn your computer off. That's like the worst one is when you haven't, even with Git, if you haven't committed and you managed to crash your computer and then you can't get back. It's like after a day's work or something. It's horrible. So, you know, you want to be able to go back in time and see the history if you break something. And it's like everybody breaks something. You should be trying to break stuff. You should be trying to push what you can do. Try new things. So one of these things, though, is like you want to be able to keep a good version that stays. Yeah, you want to be able to keep a good version that sort of just sits there happily while you go off and do your experimental things. And you can always go back to that thing. So I'm going to make experimental changes and come back. So being able to make, track, and merge experimental functionality is a big good thing while keeping a good version unpolluted. Now, this last one is what makes it hard. And I guess lots of different versions of version controls, lots of Jupyter cells, yeah. Keeping a remote backup is what makes this hard. This is a harder problem. Like if you're just doing this stuff, like you can just do it with files on your computer as long as you're diligent. Like you could have a script, you know, you could see in the bash automation, you could just write a script that every time you save it, it updates something. You could keep that through time as long as you don't mind wasting space on your hard drive. But having a remote backup for the source code in case something goes horribly wrong is why it makes version control difficult. And Git has a unique solution to this. And you want to be able to allow teams of people to work on this way with the code base without treading on each other's toes. It's like this, I had to say too much when I wrote this because it's just a lie. Like with Git, I don't know if any of you have had experience working on Git with a team of people. If you're both trying to fiddle with the same thing, it nearly always causes problems. And people, you know, you have these merge conflicts and you've got to try and sort them out. Luckily for you guys, this stuff won't happen too much. So that's what version control is trying to solve. Git is the ubiquitous tool. It was invented by the guy who did Linux, so Linus Torvalds. Don't worry about that history of stuff. It's fine. He did it for version control. Because it comes from a different time. You can use Git from command line or via VS Code, GitHub, and GitLab. So what Git actually is a distributed database. So your local repo, the thing that makes it hard is like back in the old days, they used to have version control, probably still do. Like SVN is one I can think of off the top of my head, where you have a remote database and you keep syncing up with that remote database. So, you know, that's the good version, is this remote database, and it's got backups and redundancy, and you get the changes from that and you put them back to that one. But when you get to big code bases, that gets out of control. Git gets out of control for big code bases too. It's not like it's a solved problem. It's like you imagine the code base for Amazon or Google or Facebook or anyone, or Netflix, one of those big companies, and how they deal with their source code repositories, especially when there's generated code, which is code written by code. You can make lots of code very easily. So Git is a distributed database. So every copy of Git is its own little Git repository, is its own little database that changes through time. So it does all this stuff. And then when you get the problems is keeping a remote backup or like syncing it with someone else's copy of their version of your Git repository. So that's where it gets complicated. That's where you're going to have problems. You're only going to do that later, maybe not. It's as an individual worker or just one or two people, you can keep it under control really easily. Yeah, so that's where it gets hard. That's where people get confused. So the remote backup most people use, is one of these things like GitHub or GitLab. So does everyone have a GitHub or GitLab account? I have 3. No? Okay, so I think it's actually in your homework if you've read ahead. So GitHub, I won't do that because I can go to That's not a link to actually GitLab. I thought it would be. Let's just go there. Oh, what? GitLab. So I lie, I have 4 accounts. So GitLab's a version of it. GitHub was the first one. GitHub's was bought by Microsoft a few years ago. I have a couple of accounts. You can see my activity history back here, which was for this course. This course is a GitHub repo. It's on Yoni's page. You can see a couple of people. There's 2 Paul Billettes because I'm lazy with my Git config and I don't change my alias. So this is like, you can think of this as like, this is the remote backup that I keep syncing my local copy to. Git itself is pretty straightforward. Let's do something. So I'd encourage you all get your own GitHub account. You can use GitLab if you have some strange ethical problem with GitHub. Who knows what people think. Don't have a problem which one you use. I think it's fine to have either one, but I'd just go for GitHub because everyone uses GitHub. Yeah, so I don't have much on this one. There's a couple of repositories here. So it's a blog you get with GitHub. You can make your own. If you just put some markdown in there, you can have your own blog. I'm making some stuff from the old place I used to work and friends LiDAR viewer. Not much. I'm not one of these crazy people who just got solid green, but my work one's like that. It's depressing. So this is a repository. So if you're using Git from the command line, just say if you were going to do it here, you can just take a folder that's already there and you just go git and git ---- help. So there's lots of commands here. So create an empty Git repository or reinitialize an existing one. These are the 2. For to start working, you either clone, which is you get a repository from somewhere else, usually the internet, or you can take a folder you've already got. Like if you're just working on your own and you don't care about the remote backup, you just go to a folder and git and it will make an initial repository. But you know, you guys are going to be doing it as a remote backup anyway, so you may as well go to GitHub, make a new repository. I don't know what we call it. Paul's silly test. Paul's silly test repo is available. Cool. Okay. Great repository names are short and memorable. That's not short nor memorable. So you can choose and give a description, whatever, I guess. You can choose whether it's public, so anyone on the internet can see it, or you can have a private one. I don't know if there used to be a limit on the number of private repositories you could have without a paid account. I think you get a few for free at the moment. So you can choose to make it public or private when you're making it. So to get there, I just went to repos new, just in case that wasn't clear. You can initialize the repository, you can add a README file, you can add a git ignore. So README files, you know, just a description file in Markdown of what this thing does. So that's useful. You'll see here for this course, there's a README file. It's pretty simple. It's got a hyperlink. That's actually for this course. One contributor, which was Yoni, who's making all the stuff. You can add a README file if you want. You can add a git ignore. So this is really important for if you're making, say, images, or you know, you've got some binary files you're going to make that are big and horrible. You don't want, Git is not for those things. Zoom just did something weird. I hope you could all see what was going on. Oh, it just gave me a weird message. You can add a git ignore file. So Git, you give a list of things in here that you don't want Git to track, is what it's for. So you're not gonna, Git is inside, it's doing a thing to keep track of all these changes through history. So if you have a big file that say like it's generated from code and it's an image and it's not like text, so like you change one pixel in the corner of an image, and you've got some funny encoding for the image, it's like the whole file can change and you'll have big commits in Git, which is not what you want. So I'll say a little bit later about how Git works inside. You can add a git ignore. I nearly always would do that. You can always add it later. Choose a license. There's a drop-down menu. There's a whole bunch of licenses. I'll say a little bit about licenses after I've gone through a bit about the development tools for you guys. So safe bet, just like cutting to the end of the story. Safe bet is MIT or Apache. It's complicated. You can see there's a lot. Yeah, none's not a good idea in general. I'd choose MIT. So then this is all automated for you. You can create this repository. Oh, so it's got a README that's empty. It's got a license that's empty. And now if I want to get this repository, you see this guy over here, this code one, you can click, and there's a link here. A couple of options how you can actually clone this thing. I won't, so we're just the reason this is actually why I said a little bit about SSH. This one's a good one if you don't want to be typing passwords all the time, but you need to go through a bit of a rigmarole of adding a SSH key to your GitHub account. There's instructions for doing this. I won't go through it right now. There's a GitHub CLI. I've never actually used that. This one's a basic one. I'm just going to type a password. Yeah, so I just got a question from Ethan. Maybe that's, yeah, you can, so two things. You can add a license after a repo's been created, sure. It's fine. You can't, or maybe you can, it's like, I'm not a lawyer, but retroactively applying a license, like if you said it's one and then you say it's another, and there's a significant amount of stuff in there and other people are using it, you're causing problems. So you probably want to get it right at the start if it's a serious project. A license is, I'll talk about this a bit later. I've got a little section in the notes about this because I think it's important, and lots of people coming out don't know much about, license, what they mean, what they're for. It's basically how you let others use your code and derived works from your code. I'll talk a bit about that later. So what you just have to do is go to this guy and, okay, so what command, it's saying like, if you want to get one that already exists, so you can git clone, paste in this guy. Okay, that does some stuff. If we go ls now, we'll see that Paul's silly test repo is here now. It's got a license and a README. So if we want to look at the license, MIT license. So it says a bit about legal stuff, blah, 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 whatever. But it's important. It's more important, like for you guys, the lesson would be like how you use other people's license works more than worrying about licensing for your own works. You might go off and make something genius and people will rip you off for money, but that's not such a big deal. It's more worrying about big corporations going. You just get a folder, that's fine. You just get the contents. Sorry, Aaron's question, I've got to remember to read out the quotes. What happens if you just download the zip? You'll just get the contents of the thing as a zip file. You can do it. So it's just that, it's just as a thing. So if I change the contents of the file, does it update the new file on my PC? No. This is what makes Git difficult. So this is a repo on GitHub, and then I've got a clone of that on mine, but they're actually two different things. And you have to keep them synced. This is where people's heads explode. So if you're in a large company and they all have their code repository in one place, and there's 100 developers all getting that code, everyone has to keep it together, and that's where things get really complicated. But as a lone wolf, or one or two people, you're not going to have too many problems. So anyway, we've got this guy. So let's make a change. So let's copy. So I had this UQ demos. I don't think there's anything. So I've got a bunch of Julia stuff and some silly bash scripts that are broken. Some of you guys can come and fix it up for me. UQ demos into. Okay, so I copied recursively all the things in UQ demos into Paul's silly test repo. So let's go into Paul's silly test repo. So I've got a folder called UQ demos in here. UQ demos is probably not a good name. So let's move UQ demos into source. Now it's called source. It's got all that stuff in it. Bit of command line shenanigans there for you. Got a bunch of stuff. So now, so this to your question. So even on my computer, Git hasn't done anything yet. So Git status is the one you want to have a look at. So I'm on, this is a bit of decoding. I'm on branch main. Used to be called master, but that was offensive. So they changed, most people have changed it to main now, but sometimes you see people saying master. Everyone initializes with main these days. So that's the main branch. Haven't talked about branches yet. Branches are a little bit complicated. So we'll just go, let's just make it easy for now. So there's an untracked file. So git add file to include what will be committed. So this is a folder. So I want to add everything, git add source. Git status. And now I've got all these files that I want to commit. So new file, hello, new file, new file, new file. This is a lot easier so to see on, let's open folder. I won't go 100% command line here just to make it easy. So we go source, Paul silly test repo. Okay. One of these things that, yes, I trust the authors, kind of. One of the things that an IDE will give you, we'll talk about this after we've talked about Git, is it will give you a bit of help in driving this stuff. So there's integrations with Git. So like everyone uses Git. So, you know, there's integrations with Git as a default in something like VS Code. So what it's saying is like, there's all these stage changes. So that was the same as what I had here, Git status. So what you need to do is git minus help is we want to commit these guys. So git commit. Now this is where this is why I introduced the editors before. So I've got this other random editor called Nano that's come up, and you're going to go, oh my God, what happened? This is why you probably don't want to, you want to use the VS Code one, but it's like some other editor randomly popped up. So I should have said that in the list so you can have that. Nearly all these distributions will come with like Vim, Emacs, Nano, blah, blah, blah. It's asking me to write a comment. So this is for the change tracking. So it's like, please enter a commit message for your changes. Line starting with hash will be ignored. Empty message aborts the commit. So initial, write a message. So this is for you in the future. Write a message so that you can not lose your mind later on. You can go back and understand what the hell happened. Or demo. Okay. And Control X. Yes. Okay, so I wrote a commit message, so get status. So now, this is a little bit harder to see, but so there's no changes. So I've put a commit. This is a little bit hard to see. So one of the things you can use is git log. And you'll see that there's two things here. So there's main, origin, main, and there's some local stuff committed for demo. So this is where it gets confusing. You've got this one on GitHub, and the my local one, and now they're different. So that to that question before, if I look here, you know, I refresh this, nothing's doing. It's one commit 9 minutes ago, which was the one that GitHub made to make the repo in the first place. So what I need to do, I'll just quickly introduce a tool if you're on Linux that I like. There'll be equivalent ones on Windows. I'm going to have to go and have an investigate and see what's not. It's called Git K, and it gives you a visualization of what's happened to your history. So I like this. So there's this remote origin main. So this remote one is the one on GitHub. And I've got this initial commit for the demo. What I need to do is I need to push. So I need to push my changes to the remote one. There's some stuff about like maybe somebody's been changing it over there and you need to get the changes before you do it. Talk about that later, but just for now, if you're working on your own, it's really easy. Git push. And it's like, oh, because of the way I downloaded the Git repo, I've got to go, it's me. This is where there's one of those ones where I'm going to type my password and it goes on the internet. Cool. So I've pushed it to the remote repo. So my local changes have gone onto the internet. So now, cool. Now there's this source directory here. It's got my stuff in there. Cool. So again, as I was saying, you know, GitHub, I'll try and do something a little bit naughty just so you can see, is I can actually edit on GitHub. I won't edit the license, I'll edit the README. Okay. Now it's asking me to commit. So this is just a, you know, a nice user interface for doing Git things that I was doing in the command line on the web page. So I'm going to commit directly into the main branch. I won't talk about branches for now. I'll save that for later. I can commit these changes. Now it's got blah, blah, blah. So now my local copy on this computer is out of sync with the one on the internet. So I need to keep the sync. So what the command to do is git pull, and I'll, just to show there's nothing up my sleeve, so ls, I've got the readme, vim, readme, blah, pull silly test repo. You see that change hasn't come to me yet. So you manually have to do this bit of getting the changes. So git pull. So it's got these changes. There's this change to this readme, vim, readme, blah, blah, blah. So now I'm synced up with my remote. So the workflow is always just like I git pull, make local changes. There's a few more commands that we'll teach you. Yeah, that's exactly right, Liam. So push to upload to the remote. When you're doing the setup yourself, there will be a couple of things I've missed that you'll have to worry about. So the first time you're setting up Git, you've got to set up. Oh, it's easy when you've made it on GitHub because you've got to say where the remote version of it is. That's one of these things. It's where is this remote repo for this repo? And you've got to give it your credentials. So git config. So one of these things you have to set up is your global config for Git is email. So I've got my work one here because I'm an idiot. And username. So global username, Paul Billette, blah, 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 blah. You've got to do that so it knows. That's part of the thing of config. So when you're first setting it up, you have to set those things. It'll complain when you try and push if you haven't done all that stuff. Yeah, so now, if I look at, I did just do that. So Vim readme there. If I look at Git K, you'll see there was the first one, there's the second one, there's the third one. We're all up to date. And you'll see this annoying, so like because I'm an idiot, I've set my git config as my work email because I'm lazy and I don't like changing it. I should set up a little bash script to change it or something. That's the one I made on the internet with the initial thing. It's just got the license and a markdown. Then I added the source, and then on the internet, on the GitHub version, I've changed this. So the confusing thing to start with, if you're just pushing onto main every time, it's easy. Branching is a little bit trickier. It's all about keeping sync with all these different people doing things. And the fact that it's a distributed database is the thing that makes people head explode. So I got one more question. If you made changes to the downloaded one on your computer and then downloaded the new one in Git, would it just merge the files or does it override it? It depends on how you drive Git. So it depends if you've got, so I'll do that as a demo next week, actually. That's probably a good one. I can show you what will happen, the sort of things that go wrong. One of the good things about Git is that if everything goes wrong and the remote backup's fine, the safety plan is just just delete the local copy and pull it again. You can get yourself in a state where everything doesn't work. Don't panic, because it's a distributed database, which is part of it's kind of amazing that works. It's like, in this weird way, it's a bit like the blockchain for Bitcoin or cryptocurrency or something, where it's this distributed thing that sort of can outlast religion. It's kind of an interesting design. So I got another question. So if you make a new branch, if you think you may have stuffed up the new code, yeah, so you push to the new branch. So I'll go through that really quickly next time. So you'll make, I can probably do it now. We can just go, if you click here, you can make a branch called test branch. And you'll go, there's no branch called that. Do you want to create it? Yes, I do. There's a test branch. If I go over here, git pull, it'll say, oh, there's this new branch. I want to change to that branch and do stuff. Git check out test branch. Now, if things change on master, I can change on the branch. Got to bring things back together. That's really quick, but we're out of time. So any questions on that stuff? It's a bit of a brain dump. Git is a power tool. It's a little tricky. If you're just using it naively and you're the only person using it, it's pretty straightforward. It's just pull, push. Remember, it's a distributed database. Remember, treat this guy on the internet like your remote backup, and you got to keep syncing with it. That's the problem. Any other questions, guys?
Hi, I have a question.
Yeah.
Yep. So I was kind of, it's an assignment related question. I can ask it a bit later if that helps.
Yeah. I'll just go for this one. So how secure, so one more question on the chat. It's like, how secure is it from an ethics point of view? What do you mean by ethics in that one, Katrina? I should say Git was, oh yeah, no. It's a little bit dangerous with dealing if Git was developed with the idea that it's in the open always. It's from open source. It's a tool developed by the guy who made Linux. I'll talk a bit about when I talk a bit about software licenses. So the whole idea of it is you're doing it in the open, and so you're showing your code to the world all the time. Assume, unless you've got a private repo, but you shouldn't be committing data sets. It's not for data sets. If you've got a git ignore, don't ever put all your data sets, put it in data folder, ignore everything in data. If you've got passwords or keys, this thing what I'm doing in the bash, and I'm scared of my passwords coming up. Never put passwords, be careful. And it keeps a record of everything. Unless you go and edit history, it's going to keep things there. So you got to be careful. It's for source code control, and assume it's open. Really careful. Whoops, did you just do it, Liam? Everyone's worked at a place where someone's done something bad with that. It's, if it's a private repo, it's not such a bad thing, it's not the end of the world. But working in public, if you're working in public, if you in that button where you said it's public repo or a private repo and your security on your account's not very good, be careful. Cool. Anything else, guys? Or that question about assignment? I'm happy to answer that quickly.
Yeah, so we're doing question 8B. It says determine an expression for the number of times that the function is called for an n-by-n matrix.
Okay.
And wouldn't that just be like, so I've created a function and it makes it work. It determines the determinant of the little 2x2, and it works to all of them until it gets by the little 2x2, right?
Mm-hmm.
Yeah. So wouldn't the function just go through it And so if n is 3, it goes through it once because there's only like one little 2 by 2. Or is that the wrong?
If you've got it as a recursive call for this myDet,
Yeah.
think about that. So it's calling it within itself. So if you start with a 3 by 3 matrix,
Mm-hmm.
that's how your thing works. You're going to go like, I'm going to start with this pivot point, do this submatrix.
That's one going through.
1, 2, 3. But if you might have counted the 2 by 2 one as special, like if you didn't.
Yeah. Okay.
If that's just, yeah, I'd say that was like that, counting that way. So every recursive call.
Mm-hmm. And then for question 8C, I was kind of confused on what it means. So, like test, yeah.
Yeah, so that would be like, this is like a 8B is like theoretically, given your algorithm, come up with an expression as a function of n. And 8C would be like, do something in your code to verify that that's how many times it's actually been called.
So you need to alter your code to like produce, so like say every time it went through, like produce like a letter A, B, C, D, E, F, G.
Yeah, just a counter, have some global variable. It's probably something better than global, but the easiest way would be to make a global variable, and every time myDet is called, you increment the global variable.
Yep. Okay.
You can just look at it afterwards.
Awesome. Thank you so much.
All right. Okay. Any more questions, or I'm going to run away?
I do have another quick question about the assignment, if you don't mind.
No.
Just looking at question 7A, I'm a little confused as to what the question is actually asking, what it means. Is it suggesting a different algorithm for matrix multiplication that would give a different result?
Same result, just a different way.
Okay. All right. I'll work it out. Cheers.
Yeah. So they're all just like, they should all give you exactly the same answer. It's just like, you do it by inner products, you do it by outer product, do it by multiplying by the rows. So it should all give you exactly the same answer. Like matrix multiplication is still the same thing. You're just doing it sort of like showing off in code about all the different ways you could do this matrix multiplication. So you could have a test where, you know, like AB should be the same for every version of your algorithm for every input, but that's probably a bit too much to test. So you just do a couple of cases and show they're all the same. All right, cool. Call it, guys. Thank you for turning up. All right, I'll see you guys later.